Okay, hey everybody. All right, we're going to continue with segment lengths in circles. And if you remember, we first started off with a regular circle, and we had two chords, right? And when we had two chords, remember the two chords were broken up into parts as long as they came from the same segment, right? Part times part equals part times part. So PP equals PP. So A times B, because that came from that chord, and that will equal C times D because that came from that chord. So part times part equals part times part. PP, PP equals PP. All right, the second one was two secants, right? And we had two secants. And when you have two secants, remember it was we. Right? And we was, W stood for the whole thing. So we did A plus B, because that was the whole thing, times the E, which is the exterior, and that is going to be equal to the whole of the other one, which was C plus D times the exterior, which was C. Okay. And then the last one we did was if we had a secant and a tangent, right? And for the secant and a tangent, then this one was wet, right? And it was this whole thing, right? So this is wet. So it was the whole thing, which was A plus B times the exterior, and that is equal to the tangent squared. Okay, so those are the three that we talked about. All right, there's one more actually, and this next one we're going to talk about is when we have two tangents. All right, when we have two tangents. Okay, so that's going to intersect there, that's going to intersect there. Okay, all right. If we have two tangents, and here we go, if two segments are tangent to the same circle from the same exterior point, then the segments are congruent. So now we have two tangents, right? We have this tangent and we have this tangent, but they come from the same point. They come from the same exterior point. And if they come from the same exterior point, the segments will be congruent, okay? Equal in length. So if this one's 2, this one is 2. If this one's 21, then this one is 21. If this one is 321, then this one would be 321. All right, so no matter what, if you have two tangents to the same circle from the same exterior point, they will be congruent. All right, now how is this going to help us? All right, how is this going to help us? Well, I'll show you how it's going to help us. You may have a problem like this, where it asks you to find the perimeter of the quadrilateral ABCD. Okay, so remember the perimeter is the sum of all the sides, so I need to be able to add all the sides. Currently, I only have this side because if this part is 5 and this part is 7, then this whole thing is 12. All right, so that's the only one I have. So now I'm going to use the information I just learned about tangents to the same circle from the exterior point. And what that helps me with is this one. If this is 5, right? If this is 5, then this one has to be 5, which then makes this this entire side 7, because if that part is 5 and this part is 2, then that is 7. Um, Over here, if this was 7, then we know that this has to be 7 as well, which means if that part is 7 and this part is 6, then this entire thing is 13. Okay. And then we have, of course, if this one is 6, then this one has to be 6. And if this one is 2, then this one has to be 2, which then allows us to say that this entire side over here is now 8. we now have the lengths of all the sides. We can easily come up with the perimeter of that quadrilateral. Okay, and the perimeter of that quadrilateral will be the 12 plus the 13 plus the 8 plus this last one, 7. Okay. All right, and then you just add those up, and you will see that the perimeter of quadrilateral ABCD is 40 centimeters. All right. All right, let's look at one more. Let's just practice this one more time. All right, let's find the perimeter of this figure. Okay, find the perimeter of this figure. Now, this one is a little bit different because you actually have some work to do in order for you to do this. Okay, so I'm going to give you a chance. Go ahead, pause the video for you to draw this. And then once you're done drawing it, hit play so you can kind of, or even try to work it out before you hit play. All right, but I'm going to work it out. Okay. All right, so I see that this one is 11.6, which means this one is 11.6 as well because they are tangents to the same circle from the same exterior point. So right now I can, and then which allows me then to add those two parts to get this 19.7 here. All right, so now I have 3 of the 4 sides. Unfortunately, my final side for me to find would be this one right here. But in order for me to find that, I have to get this part. Okay, which means you're going to have to kind of work backwards, right? So if this part right here is 8.1, I know that this part is 8.1 as well. Since the whole thing was 22.1, if I subtract 8.1 from the 22.1, I will see that this part down here is 14, which makes this part right here 14. And if that part is 14 and the whole thing is 19.6, if I subtract 14 from the 19.6, I will find that this is 5.6, which means this has to be 5.6. So I had to work my way backwards to get this part right here, but then now I can add those two together. The 11.6 and the 5.6 gives me 17.2. So I now have all 4 sides. I have all 4 sides. So now I can find the perimeter by adding up all 4 sides. So I will be adding 22.1. I will be adding the 19.6, the 17.2, and the 19.7. I did not pull up my calculator, so I'm going to do this old school. Let's see, 1 plus 6 is 7, 8, 9, 9 plus 7 is 16, carry the 1. 1 and 2 is 3, plus 9 is 12, plus a 7 is 19, plus another 9 is 28, so put the 8 and carry the 2, and 2 plus 2 is 4, 5, 6, 7. So the perimeter of this quadrilateral is 78.6. 78.6. All right, I hope you enjoyed this final section of 10.5. And I will probably do a couple problems tomorrow, and then you'll have a worksheet the following day. Hope everybody is doing well. Please believe me when I say I do miss you all. All right, have a good one.